Today in Campechi's Corner, we're going to talk about differences of squares. Differences of two squares is when we have a perfect square minus a perfect square. And so when we have that, we can factor that into a plus b times the quantity of a minus b. Now remember, when we're factoring, the opposite operation there is FOIL. So what happens is we get a times a, which is a squared, and then our outside is a times negative b, which would be negative ab, and our inside would be a times b, which would be positive ab, so our outside and inside terms would zero out. Then we're left with minus b times b, which is b squared. Now example we have down here, so if I have x squared minus 9, which is a perfect square minus a perfect square. Any variable to an even power is a perfect square, and we know 9 is a perfect square because 3 times 3 is 9. So this factors to x plus 3 times the quantity of x minus 3. Now we're going to factor, and number 1, the first thing we're always going to look for, again, is our greatest common factor, which we don't have one. And so we have m squared minus 4. So m squared is a perfect square, and 4 is a perfect square. So I can set up my two binomials. The only way I'm going to get m squared is m times m. I know when I have a perfect square minus a perfect square, or difference of two squares, I'm going to have 1 plus and 1 minus. And the square root of 4 is 2, so I get 2 times 2. Now again, we can check this. First is m squared, my outside is negative 2m, my inside is positive 2m, and my last term is negative 4. These terms in the center, my outside and inside, will zero out, which is why I'm left with m squared minus 4. So I know I did this problem correctly. And number 2 again, I'm looking to see if I have a greatest common factor, which I don't. 4k squared. 4 is a perfect square, and k squared is a perfect square. Minus, and then 25 is also a perfect square. So I'll set up my two binomials. The square root of 4k squared is 2k. So we have 2k here and 2k here. I have a plus and a minus, and the square root of 25 is 5 and 5. And number 3, same thing. I'm going to look for a greatest common factor, which I don't have one. 36 is a perfect square, so is y squared, and so is 1. Remember, 1 is a perfect square. It's 1 times 1. So I'll set up my binomials. 36y squared, the square root of that is 6y. So we have 6y and 6y. I have plus and a minus. Square root of 1 is 1, so I have 1 and 1. So I have the quantity of 6y plus 1 times the quantity of 6y minus 1. Now in number 4, I don't have a perfect square, but I do notice that it's not in standard form. I want that x squared first. So I'm just going to rewrite that. So I'm going to write negative 49 x squared plus 25. Now 49 is a perfect square, x squared is a perfect square, and so is 25. However, I don't have a perfect square minus a perfect square. But I do notice if I factor out my negative 1, I'm left with 49x squared minus 25, which really is a perfect square minus a perfect square. So I have negative 1 times the quantity of 49x squared, the square root of 7x and 7x. The square root of 25 is 5, so I have plus and a minus, and I have 5 and 5. So there's my final answer in factored form. In number 5, I don't have a greatest common factor, but I notice that 16 and a squared is a perfect square, and so is 121 and b squared. I have different variables, but a squared and b squared are both perfect squares, so I'm okay. So I'll set up my two binomials, and I have 4a and 4a, and I have a plus and a minus, and the square root of 1b squared is going to be 11b, and then minus 11b. So there's my final answer in factored form. In number 6, I notice I have a greatest common factor in this one. 5 goes into both 45 and 20, and then I have a to the 4th and a to the 2nd. So I can factor out an a to the 2nd. And I'm left with 9a to the 2nd minus 4. So I have 5a squared, and I have, that's 3a plus 2 and 3a minus 2. So here is my answer in factored form. The last problem we're going to factor today, I have 2y to the 4th minus 50, and I do have a greatest common factor, that's 2. So I'm left with y to the 4th minus 25. I'll rewrite my greatest common factor. Now this time I have y to the 4th, and it is a perfect square because y squared times y squared is y to the 4th. Any variable to an even power is a perfect square, and 25 is a perfect square. So I'm left with y squared plus 5 and y squared minus 5. Now we're going to practice solving a few problems by factoring. So we're going to start by factoring like we have been in the past few problems. I look for a greatest common factor, and I don't have one, so I'm going to set this up. I notice that 16 and x squared is a perfect square, and so is 9. So I have 4x and 4x will get me to 16x squared, a plus and a minus, and then the square root of 9 is 3, so I have a 3 and 3. That's equal to 0. Now remember, by the zero product property, either this binomial or that binomial has to equal 0 if I'm saying the product is 0. So I'm going to set them each equal to 0, and I'll solve from there. Bring my 3 to the other side, so I have 4x is equal to negative 3, so x is equal to negative 3/4. And my other binomial, again, this time I'll add 3 to the other side, divide both sides by 4, and I have x is equal to positive 3/4. So there are my two answers, negative 3/4 and positive 3/4. In our last problem for today, we're going to solve, and I noticed that my equation is not set equal to 0, so I'm going to do that first. My highest power is a 3, and my leading coefficient is 18, so I'm going to leave that on the left-hand side. I'm going to bring this negative 50x to the other side, so I'm left with 18x cubed minus 50x is equal to 0. Now I have a greatest common factor. 2 goes into both 18 and 50, so I'm going to factor out a 2. I also notice I have x to the third and x, so I can factor out an x. So my greatest common factor is 2x. Then I'm left with 9x squared minus 25 is equal to 0. Now I notice I have a perfect square minus a perfect square, so I'm going to rewrite my greatest common factor. Square root of 9x squared is 3x, so I have 3x and 3x. I have a plus and a minus, and square root of 25 is 5. Now again, we're solving, so if I know that when I multiply these three things, I get 0, one of them has to equal 0 by the zero product property. So I have 2x is equal to 0, 3x plus 5 is equal to 0, and 3x minus 5 is equal to 0. Divide both sides by 2, I have x is equal to 0. That's one answer. I can bring my 5 to the other side, so it becomes negative 5. Divide by 3, so I have x is equal to negative 5 over 3. And my last problem, the same thing. I'll bring my negative 5 to the other side, gives me positive 5, so x is equal to 5/3. So my final answer when I solve, I have x is equal to 0, x is equal to negative 5/3, or x is equal to positive 5/3.